Okay. Thanks a lot, Fabian. So before we get started, we need to clear this up right now. It's now been said twice. Yesterday, I was told that I had to Google it and find out myself. So I did. I'm not sure what Leo thinks of me now. But it's definitely not that. There's not enough wine to get me to do that. So let's talk technology and try to erase that from our eyes. So what we're going to talk about today are some stuff around application resiliency and reliability. A number of the talks yesterday and a couple today maybe even talked about things in the cloud. And the cloud is a great place to put applications when you need infrastructure reliability, failover, redundancy, any of these things that are related more so to hardware and networking. There is a little bit of stuff in the cloud that helps you with code reliability, but not a lot. That's all left to us as programmers. So I want to look through 3 different things today that we can do in our code base to help improve the reliability of our code. The first one we're going to talk about is tuples. Is everybody familiar with what a tuple is? A few of you. So this is a newer feature in .NET. I believe it came, or in C#. I believe it came in C# 4. I might be wrong on that. The tuple is a relatively simple data construct. It allows us to create a dynamic class, in essence, that has a number of different data values inside of it, and we do this generically. It's a simple syntax. We can use anything from 2 to, I believe it's something like 70 or 20 or some ridiculous number of values. What we normally see in code a lot of the time is something like this. We need to initialize some values, and we need to do it at the same time, so we pass it into a method. Initialize the customer and the invoice. This is something that may happen inside that method. We go in, we take the customer, we set the name, we take the invoice, we set a value on the date, and that is considered initializing the objects. There's a problem with this. When we're consuming that initialize method, we don't know what happened, or if anything even happened, to those 2 parameters that we passed in. This is a lack of clarity, and we usually refer to this as unintentional changes. So we have something, and it's been unintentionally or unknowingly changed in our code. The readability here is very, very difficult. We can use a tuple to help us solve this. The first option that we have, though, before we jump to a tuple, is that we can initialize each item separately. This takes a lot of work. It's a lot of boilerplate code, and things aren't bundled together nicely in some cases. We have an initialize name from, an initialize date from method, and they're called one after the other. We could change this and say get the name and get the date. It's not much different. It's a little bit clearer, but not a lot. This is using a tuple. So we call our initialize method, and it returns the values back. So when we're writing code, it's better for us to return values and then alter something than it is to alter it in a hidden place, like a method call. So this initialize call is returning back a tuple that we've called results, and then we can set the customer name and the invoice date using results.item1, results.item2. So So this is the tuple structure. We've said that when we've defined it, we've said there are two different values on it, and they're named item 1 and item 2. If we'd put 4 on there, there'd be item 1, 2, 3, and 4 available to us. Inside of the initialize method, it's going to look a bit like this. We're going to have our return value be tuple of string and date time. We've said we want 2 values back, 1 being string, 1 being date time. And instead of altering customer and invoice inside the initialize method, we return those 2 values back out. The reason we're still passing it in here is that more than likely when you do initialization, you're going to grab different values from those classes. So it's entirely possible that it might be a parameterless initialization. It's entirely possible. You don't have to pass the values in still. So it's pretty simple what we need to do there. Return back whatever we need instead of changing it in a hidden place and having these unintended consequences happening. Unfortunately, tuple came pretty late in the framework game, and the result is that we have stuff built into .NET that doesn't use this tuple pattern. We've probably all used try parse. Try parse has the out parameter. You pass in a string to get a date time, so convert a string to a date time in the first one, and it changes the result variable that you pass in and return something out. This would be better served with a tuple that had a Boolean saying true or false, we succeeded or we didn't, and a date time that contained the value if it did succeed. There's no changing of variable values in the background or any kind of memory location value in the background. Much simpler pattern to use. Try parse, this is the pattern for try parse in the .NET framework, unfortunately. So the benefits we get from tuples are we avoid these side effects, these unintended consequences. We avoid the use of out parameters. Out parameters in general are just a crazy idea. It allows us to send multiple return values back, but that's exactly what tuple does. We can make a tuple of customer invoice and send those back instead of having customer and invoice being out values. And we can have all kinds of values coming back without having to specify a class structure. So we don't have to create a customer and invoice initialization class and have that have properties on it. We can just say, we need this quick, simple structure. We'll use a tuple for it in this case. So this allows us to create code that's easier to understand, and we don't miss the changes that are happening in it. So this is a big thing for doing resiliency in our code base, is allowing things to happen without surprises. So that's tuple. The next one we're going to talk about is called the null object pattern. Is anyone familiar with the null object pattern? A few of you? This is a well-defined pattern. I can't remember what book it's in, but it is in one of the big books on design patterns. The null object pattern is about handling null values. So we usually see code like this. And what we've got here is up at the top, we've got a constructor for my class. It takes in some type that implements iLogger and sets it to this private variable. Then throughout the rest of the class, this my class, in the different methods it has, you'll say something like, if logger isn't null, go ahead and do a debug or whatever type of logging you need to do on it. This is pretty standard pattern up here for dependency injection. And if we do that and we don't do this down here, it's entirely possible to pass null in. And now we've got null for underscore logger. And if we don't do this check, null.debug does what? It breaks, right? So what we have to do is put that check everywhere. If we don't do that, we're not doing good defensive programming. That's a lot of boilerplate code to have to remember to do. The first time you forget it, boom, your application stops working, right? And that's not good. For something as simple as that, it's not a good scenario. So what we do with the null object pattern is that we create an object to use in place of null. So in this case, we're implementing iLogger on a class we're calling the null logger. We go through the iLogger interface and implement everything that's necessary on it. In this case, we have debug, but you probably have debug and error and maybe info or whatever types you have. And you do absolutely nothing inside of them because you want it to act like it's not there. The null logger is like it doesn't exist. So now we've got a class that does nothing, but it looks like the proper object type. So we're able to go into this class where we injected it before, exact same code here for injecting it in the constructor, but instead of putting it into underscore logger that hasn't been used, we can say that by default, we want this to be a null logger type. This doesn't prevent somebody from passing null in, so we could do something to ensure that there's never a null in there, but that would be probably in our inversion of control container. So say we've done that, we can never get null through here now, and we have null logger as our type. When we get down here, we don't have to check and see if it's null anymore, because it's always going to be something other than null. And when we run logger debug, it does nothing. The application just keeps right on working. We never worry about it blowing up anymore. So the null object pattern is a really, really simple pattern. And it's one that I use a lot for classes that I usually would have to do an if equals null kind of check. The benefits from it are pretty simple as well, right? We eliminate null checks. You don't even have to think about them anymore for certain objects, which means that you'll never forget them. And it's a crazy simple pattern to implement. All you have to do if you're using a tool like ReSharper is say implement the interface, implement all of the constructs on the interface, and then go through and delete each of the throw new not implemented exceptions, I believe is the default. You just delete those, leave it blank, and you're good to go. Where this doesn't work so well is if you're returning values back from those. So if our debug call here returned a value back, you need to figure out what is the appropriate default to send back. You probably aren't going to want to send null back if that's an option, because now you've got the null problem again. So this is really good for method calls, not so good for function calls, but it can be used for both. So that's two of our three things. We're going to be out there at the party having beer in no time. Except for the fact that I've still got 46 more slides to go. How many people are familiar with the circuit breaker pattern? A few people? This pattern is not defined in any of the big pattern books, unfortunately. It's a well-defined pattern, it's just not in the big pattern books. The place that it really first got some attention was in a book called Ship It. Say that fast 3 times. The circuit breaker pattern is about adding resilience to your code in the face of mostly networking and distributed application problems. So before we jump into what there is in the circuit breaker pattern, let's talk about retries in your code. I'm sure almost everyone in here has either worked on or written code that goes out and calls some external dependency, a web service or a web API to get data into the application to use, right? When you do that, do you retry that call if it fails? How many people write retry code for a call to a web service? One lonely guy. Two, okay, you're not so lonely now. A few of you. It's something we should do, because why can that call across the wire to a web service or web API endpoint fail? Might be as simple as a drop packet on the network. That doesn't mean that the service is unavailable or it's erroring. We had an infrastructure problem. So if we retried, the next time the packet might not be dropped. We might get success. It's the most basic reason for doing it is that type of thing. Maybe the web service, the application is just starting up, and the web service and IIS hasn't finished its startup process yet. But somebody hits the front end of the application and makes the call and gets a 404. If they tried again, it might be ready, because IIS can start up and flip from off to on that quick sometimes, right? So we should be doing the retries. The question is, how should we do these retries? This is usually the pattern we follow. We have our application, some other web API or some third-party external dependency, and we try it and fail, try it and fail, try it, fail, try it, fail, try it, fail. Hey, we succeeded. What have we just done to this over here? We just did a denial of service attack on it, right? We're endlessly retrying until we succeed. Put that on a website and have 100,000 people hit it. You think that's going to survive? Probably not, right? So we realize this, usually after we've released it to production and brought our services down. And we say we're only going to, so this is the problem, is when we have this, we try for n times, and it's y number of clients, and that's the equation for how many times we're hitting it. Denial of service attack. So the next step is that we limit the number of retries. We say this can only retry in a loop 1 to 5. Instead of do while we're getting an error, we say for I equals 0 to 5 or 0 to 4 or something like that. So instead of n times y, we get 5 or whatever number we pick times y being the number of clients. Y is still the problem we have here though, right? Because each client doesn't know that the other is trying and failing over and over again. So while it's not a full-blown denial of service attack, it still has the traits of it. We're just hammering the living crap out of that back end. So let's go back to circuit breaker. Everyone know what a circuit breaker is? Is that something that translates well down here? For the physical circuit breaker in a house? Like this? Okay. Well, you never know. It could be different. Circuit breakers are in a house or a building, electrical system, to prevent overloads of the electrical system, right? They have pretty simple pattern. They're on or they're off. Electricity can flow or it can't flow. And they only really move one direction. They move from on to off automatically. The circuit gets overloaded and bang, trips it, and you got no electricity, and you hope to God you saved whatever you were working on. I experienced this 2 days ago. I was trying to be a nice person and share the one plug-in in the hotel lobby with Rachel, which was my first mistake. So I took my little adapter, and I have a little travel power strip. I plugged the power strip into it, and I took the adapter and I plugged it into the wall. And bang! Yeah. I thought that little power strip was just going to be fine. It wasn't taking load. Apparently it did. So after about 40 minutes, when I was brave enough to try the power plug again, we did it without the power strip, and the power plug didn't work. It went from healthy to not healthy because we killed the circuit, overloaded it, whatever electrical term you want to use. It did its job, though, right? To stop us from causing a problem to the back-end systems, like burning the hotel down. It's the last thing I want to be responsible for on my first trip to South America. So it automatically made that trigger and that trip. The other direction of taking it and fixing it, which we never told the front desk it needed to be done because I was too embarrassed, is done manually. You have to go to the breaker and physically move the lever, right? So that's the two phases and the two steps that happen with a physical electrical circuit breaker. So we've talked enough about physical stuff, and you guys don't want me to dance, and you don't want me to dance in Leo's little image of me here. So, in software, we can take the circuit breaker, the physical circuit breaker process, and implement it as part of our retry. So we have some third-party, whatever external dependency here, and we know whether it's healthy or not healthy. If it's a web API or an ASMX, we can just go and say, give me something. And it will get a 404, we may get a 200, but if we're not getting a 404, that's good. It's healthy probably then, right? Or at least it's initially healthy. So we can make that determination of healthy or not healthy on our dependencies. That health, or lack of, is completely independent of our other application, because it's probably running in another process in IIS, or at least it should be running in another app pool in IIS, whether that's on another machine or the same machine or whatever. So it's independent of the front-end application, whatever that is. We've also got our application. Our application's sitting wherever it's sitting, and it may have one or more of these external dependencies. And external dependencies include a lot of different things. So I've used the example of web API and web services because it's a really common one. But what about a database? It's running out of process to your application. It's an external dependency. What about the file system? If you're saving files that people upload. How many people have had an application go down because it's run out of hard drive space? Wow. All right. I'm not the only person out there. I'm not going to admit to writing the code that did it, but these are external dependencies. So we always have lots of them, it seems like, in applications. Maybe multiple API endpoints. It might be multiple different services providing those endpoints. It might be multiple different systems, but we have a bunch of them, and our application relies on them. Our application, because we own the code in it, we can throttle it. We can say, try hard, don't try so hard to get the connection to this external dependency, right? We can write the loop, do while, or we can write it for I equals 1 to 5 kind of thing. We also, because we control this code, are able to say, try, and now just wait a few seconds and try again, or wait some time period before you try again. This is the same thing from the physical circuit breaker. So our application is what was plugged in, and it broke. our application is the person going to flip it back on as well. Because we don't want this circuit breaker thing to require manual intervention in our software. So our application acts like the person flipping the breaker back to the on state. As we would do, and as the hotel we're staying in is currently doing, they're waiting for some period of time before they try it again. They're not going to try again until they're told or someone figures out it's broken. But you can say, my application should wait 30 seconds or something like that before it tries to connect to this other system again. And the reason we want to do that is that we don't want to denial of service that system. If that system's trying to get itself back on its feet because of some failure or the app pool recycled or something like that, we don't want to beat on it while it's trying to stand up. We want to let it stand back up. So we can put this wait period in. So let's look at a common scenario of how this works. We've got our application, this concept of the circuit breaker, and our dependency. Our circuit breaker is currently configured to say a threshold of 2, meaning it can fail up to 2 times before the breaker trips. We're going to pause for 10 milliseconds between each of those attempts. We don't want to say, oh, it failed, try again. We want to say, oh, it failed, wait for 10 milliseconds to let it try and come back up and try again. We have a timeout, in this case 30 seconds, that says once the breaker is tripped, wait for 30 seconds before anybody can try again. And in most applications, you start with the state of a breaker being closed. It's really confusing, the terminology used for circuit breakers. Closed is good. Closed means that the wires are touching and electricity can flow. The wires are touching and your application can transmit data or try to transmit data. So the first thing that happens is our application sends a request. It goes through the circuit breaker and then on to whatever we're going to. Let's call this a web API. So the request goes to the web API. It fails. We now have a failure count of 1. We wait for 10 milliseconds because that's what our pause period is. We try again. You notice it doesn't go back to our application. The circuit breaker says it's time to try again. So it tries again, fails. We've got 2 failures. 2 failures is our threshold. So it changes the state from open, or from closed, where things are connected, to open. And it returns an exception back to our application saying the operation failed. We tried as much as you wanted us to try in the way you wanted us to try it, but we couldn't make this happen. So this is just one person. This is Joe user clicking save. One person, and that's what happens. Once that's happened, maybe Mary comes along and tries to do something. We're now exactly the same configuration with the exception of the fact the breaker is open because the first user tripped the open state. So the next user makes a request, goes through the circuit breaker. Circuit breaker says, hey, you wanted a 30-second timeout. I can't do this for you because 30 seconds hasn't passed yet. So it sends an exception, in this case a circuit breaker open exception, back to the application. It doesn't even try to get over here. Right? This is us preventing the denial of service. The application, Mary's impatient. She's just hitting the button. Because no users do that, right? She makes the request, says, calm down. 30 seconds hasn't passed yet. Sends the same exception back. And this will keep going on until 30 seconds has elapsed since it opened. Not since the last attempt, but since it opened, or Yeah, since it opened. See, I'm already confused with open and closed. So this allows the system to try to stand back up, uninterrupted for 30 seconds. It doesn't matter which users or how many of those users are trying to get to it, they can't get through the circuit breaker. They get this for 30 seconds, and that gives 30 seconds for that back-end system to stand up. 30 seconds in this case is an arbitrary value I picked. You would pick something that would make sense for your applications and your dependencies recovery time and things like that. But whatever that period of time is, that's how long you're giving this system to get healthy again. So our 30 seconds has passed. Mary's still sitting there. The difference we have once the 30 seconds has passed is that we have what's called a half-open state or partially open state. This doesn't exist in a physical circuit breaker. Physical circuit breaker has 2 states. The software one has 3. And the half-open state is going to say, all right, I've waited my timeout period. I'm willing to give this a try again. But I'm going to give you 1 try. I don't want you to beat the crap out of the back-end system. So Mary hits her button. It goes through the breaker, makes the request. The back-end system hasn't recovered yet. So it throws an error. And we go, and our failure count equals the threshold, essentially, at this point. And the breaker says, I'm going back to an open state because the back-end system isn't ready for you yet. So we throw an exception back out of the breaker. So now we're in the same place we were during that 30-second period. But we tried it. We said, hey, we'll give it a shot. We're back at a 30-second wait period now to let the system get back up. We're not going to DDoS it by saying, flip it right straight to a full open state. That's the worst thing you can do to a system recovering, is flip it to a full open state, because everybody hammers it again then. So this is where we end up. We try again. 30 seconds has passed. Mary's poor little finger is getting really tired now. We go back to the half-open state. We make the request through, and it succeeds. We get a response. So the failure count goes to 0, and the state is set to open. We're back in closed. We're back in business. I see green, I think, open. We're back in business. Everybody can go through now. Somebody proved it's working. So we send the response that came from the external dependency back to the application. Everything looks like normal. So as I said, we have 3 states. Closed and open, which is like a normal breaker, an electrical breaker. And then this half-open state, which is a step towards being functional again, preventing the denial of service, allowing a little bit more breathing room still for the back-end system. So this half-open state is kind of like a manual flipping of the breaker. If you've ever flipped the breaker and the circuit's still loaded incorrectly, you'll flip it and it'll snap right back. That's what the half-open state is kind of emulating. So we had 2 other concepts in there when we looked at this. We had pause and timeout. And these are pretty important concepts. Pause is the period of time between the calls when we're in that little loop of try, fail, try again, fail, try again. If the call goes all the way through and succeeds, the pause is never used. It's only used when there are failures in this looping process. Timeout is that period of time to allow the system to stand back up gracefully. So we went through all of those steps and all the different scenarios there, and the one thing that most of them had in common is that there were exceptions in them, the failure scenarios. And exceptions are important as part of this process. there's two big exceptions. There's three of them that are really used, but two are the big ones. The first is the operation failed. And it's an aggregate exception. So this is when you go through and you try 5 times or whatever number of times you try, and you get a failure on each one. You have it as an aggregate exception because you want to capture every one of those errors. It might not error for the same reason. You might get a 404, a 404, a database not available. Okay, that means that we went from IIS being down to something else. And then you may get, I don't know, some other nasty errors or something like that. So you want to know what all the errors are, because that can help you diagnose what is causing this outage, or whatever the scenario is here. So this is we failed a whole bunch of times, and we're going to say trip the circuit to an open state. You'll get this type of exception out of it. The circuit breaker open exception is just a standard exception. This is when we call through the circuit breaker and it's already been tripped open. We don't go and try to connect to the dependency. So it's just a simple, normal exception. It'll have a message like, circuit breaker is open. Maybe the circuit breaker name, a couple other pieces of information, but it's a basic, simple exception. The one thing we don't want to do through all this process is lose the exception information. Exception information is really important to us. It helps us debug and diagnose whatever problems are happening behind the scenes. So there's a couple things we want to do. The first one is we always want to make sure the inner exceptions of whatever exception was thrown are passed back through these exceptions that we just went over. But there's another type of exception that we need to worry about and capture the data for. So we have our scenario again. It's a simplified, we're not talking about the timeouts because we don't care about them in this situation. So our circuit breaker is currently closed. Things are good. The applications are communicating front end and back end. We make the request, it goes through the breaker to the dependency, and it fails. So we've got a threshold of 3 here. We failed once, this case with a 500 error. We try again. We fail a second time. We still have one more time to try, so we do it. We succeed. We return the value back to the application. So as far as the application front end is concerned, this looks like it worked, right? We got data all the way back through. We made our initial request. We never see or know about what this is. We get a response. Looks like it works. Might have taken a little bit longer, but it looks like it works. What about these, though? Does anyone here think those might be important? You don't know they're happening. That's the problem. You don't know they're happening. Because the circuit breaker is making the application look like it works right over here. So what if they are happening all the time? What if you have a really flaky network? And it's dropping packets. And instead of 500s, you're getting 404s. But it looks like the application's working good. Every so often, somebody might get an error. But most of the time, it looks like it's working good. We're not returning back the exception to the application here, so we don't know about it. These are still important, and we've got to figure out how to deal with them. What I've done in the different circuit breaker implementations I've built is I treat these as what I call silent exceptions. Because they're exceptions that happen, but they don't make any noise as far as breaking the application like a normal exception would. I usually have, at this point here, where a failure has happened when we call a dependency, I raise an event. The circuit breaker has an event on it that gets raised. And then our application can listen to that event if it wants to. All the event is saying, silent exception happened. That's all it does. You can log it then, do whatever you want. It doesn't just disappear. So instead of logging it as an exception at this level, maybe you just say, this is info. And you make an info log entry. And now you've got that information. You can go through your logs and see how often does this stuff really happen? Is there some shit going on we need to fix to make this application work better? Because ultimately, we shouldn't have these. We want to get rid of that stuff. We want this to go through and succeed right back every time. So if we find these, we should fix them. If we log them, we at least now know that they're in the log. And then maybe one day, 5 years from now, somebody will read the log and we'll actually do something about it. Because that's how often logs get read, right? So we want to make sure we don't lose those exceptions. The other thing we want to do is take a look at what these external dependencies are and look at segregating them. We don't want to treat a database dependency the same as we treat a web API dependency. We probably want to have different retries, counts, maybe different timeouts, pauses, and we certainly don't want a web API to open a circuit that is also responsible for wrapping around the database calls. If the web API goes down, the database should still be up and available, right? So we want to do this kind of segregation. And it's pretty easy to do. All we do is name our circuit breakers and use the different named ones in different places. So in this case, we've got one for the database and one for a weather service. We'd wrap the weather service code with the bottom one and wrap any database calls we wanted with the top one maybe. I worked on a project about a year and a half ago now where we had basically this exact scenario, except we had multiple database backends in the app. So we had multiple breakers. We had one for a SQL database, one for an Oracle database, and we kept those segregated because they're different backend systems. We had different weather service type scenarios. We actually had a weather service, but it was different than the other services. So we had two different breakers for services. You could go as far as looking at the endpoints. And in some scenarios, you might want to have one specific endpoint in its own circuit breaker, while the rest of the endpoints from that same service provider are in a different breaker. You might want to have one method call in one endpoint on a web service being in its own breaker. So you want to look at all the different dependency types and categorize them in a meaningful way for what you expect the interaction and the dependencies of uptime to be. So the next question we usually ask ourselves is, where do we put circuit breakers? Circuit breaker isn't a component. It's not like a router or a hub. It is just a piece of code wrapping another piece of code. So we've got our application and our dependency. If our dependency is something like a web service, we've gone into Visual Studio, we've said add web reference, and it creates some god-awful generated code that is now part of our code base that is responsible for doing that communication to this piece, right? That's this. Basically, a proxy is created. Proxy class, proxy pattern being a way to hide the implementation of communication to other things. Our circuit breaker fits in around that proxy. So we call the circuit breaker calls the proxy. The circuit breaker calls the proxy using the looping pattern and all the timeouts and that kind of thing. So it doesn't exist in whatever's over here, because quite frankly, whatever's over there you might not have access to, right? You might be using Weather.com's Weather API. They're really going to let you go in and put a circuit breaker in their stuff, aren't they? So you put it in your code at the last possible moment before you communicate with that stuff, which is usually some kind of proxy. The one thing you want to watch with this is where you put and where you have proxies. If you're building a web app, it's pretty common to have a UI tier, so it's maybe your MVC stuff. That calls off to a web API tier, and that calls off to the data access tier. In that case, where do we put our circuit breakers? As far as this web service is concerned, the database is its external dependency, right? That's what it's calling to. As far as my application is concerned, the web service is its external database, or its external dependency. So in the web service, we put a circuit breaker around the database calls. In the application, we put a circuit breaker around the web API or web service calls. Did anyone see what's going to happen here that's not good? We succeed on this call. Fails, 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 sends an exception back. So we're able to contact it, but we've got some kind of exception happening in the system back here. So successful call through this way, failures here, sends an exception back here. This circuit breaker is then going to say, well, I got to retry. So it's going to send it through. This is going to say, what the hell, man? I'm open. Can't you see I'm open? You just opened me, for Christ's sake. So it's going to send back an open circuit exception. This is going to say, well, I'm going to try again because I haven't reached my limit. It's going to go through. It's going to say, dude, I'm still open. Send an exception back. This circuit breaker is going to say, oh, I tried 3 times, so screw it. I'm throwing an exception. Our application gets an exception. That's pretty chatty for a failure, right? So you got to watch for this scenario. I had this happen on an application. We had this exact structure. And so this was the magnification of the problem that really brought it to light for me to look at for future implementations. Database had some error. It was an incorrectly formed view. So the view was just blowing up in Oracle. This was failing, of course. Each one of these failures in here had the silent exception event being raised, which was triggering a logging message, which at that time we were treating like any other exception, which was going to the central logging system. So this fails, goes to central logging system. Central logging system says, error! Big swash of emails go out. So it tries again. It says, shit, error. Sends an email, or sends the central logging, which sends a big swash of emails out. And tries and tries and tries and tries. So by the time you've done this 3 times, you've sent 3 sets of emails out to however many recipients there are on the central logging or exception logging mailing list, which was the entire IT department. Then it comes back over here and says, ooh, error. Let's send out another email, because 3 aren't good enough yet. Tries again. This says, I'm throwing an exception, so we just get into this, let's send a whole shitload of emails scenario. Our retry here had been dictated to us by our architect. I don't use that in a bad way. As being very short. So when this breaker would open up and when this breaker would go to half open states, it was a period of like 1.5 or 2 seconds, something very quick like that. This UI had a piece of code that was a grid that auto-refreshed. frequently, meaning every 5 seconds. And it was open on about 30 or 40 screens at one time. And this was the minimum it would be open on because they were status update screens. So you can imagine what that did to the number of exceptions being raised here, and then here, and then here, and here, and here, and here, and here, and here. This problem, of course, happened on day one of production. And I got the first email from the exception system, central logging, whatever it was called, and I was like, okay, problem, gotta solve it. I start looking at it. Outlook refreshes, I'm like, holy, I'm getting a lot of emails now. So I copy and save one and close Outlook because that's how you get rid of a lot of emails, right? I'm looking at it, it takes a little bit of time to solve this problem, to figure out, because I have to trace through that it's not really a problem here because I'm seeing exceptions from that layer. And I have to get through to here and say, okay, it's a problem here, now let's trace the source and then figure out it's a view and all that time. Takes a lot of time. I open Outlook up to send out a status update saying, yeah, I found it. And 20 minutes later, I'm able to get Outlook to respond. I kid you not, I had over 3,700 emails in my inbox from this alone. We brought the Exchange server down. The lesson here is really pay attention to when you have this multiple scenario thing set up. Really pay attention to how long you're pausing for before you try and stand up the connection. Here, in our case, again, don't wait for 1.5 seconds. Maybe wait for 3 or 4 or 5. Also, really know what the communication from the front end is going to be like. We were totally oblivious to the fact that we'd written the code to do this refresh and the impact it was going to have if something broke. We never thought about it. So you really got to watch for that. But it's not a problem you can't solve. Right? First thing is don't send the damn emails out. If there's silent exceptions, or like we treated these down here mostly as silent exceptions, don't log them as exceptions, log them as information. They're not really the application breaking in some cases. So just say, here's some information. That would have prevented us from sending out probably somewhere in the neighborhood of 60% of our emails. So you have to think about this scenario. It does happen, and it always happens at 8 a.m. on the first day of production. So the basic circuit breaker pattern, it's really all about retry looping. It's about doing it in a way that is controlled and makes you a good system neighbor. You're not the person trying to get your work done, but negatively affecting other things. So it's about being a good neighbor while still trying to get your job done. That's the circuit breaker pattern. Not one that's used very often, but one that has huge benefits for adding resiliency and reliability into your application. So before I finish up here, we need to say thank you to these guys. They did an absolutely brilliant job. I've been lucky enough to be to a huge number of conferences around the world, and I haven't seen one that has been as well set up as this, considering it's the first time it's ever been done. So they did an amazing job. So thank you to Fabian and the rest of the guys.